My name's Evan Haug. I'm the CEO and co-founder of Leaf Automation and former electrical engineer in the construction engineering industry. At Leaf, we're building machine learning automated CAD design for commercial system engineering. And what I mean when I say commercial system engineering is I'm talking about the conduit routing, the HVAC routing, and the plumbing routing. And while all of these problems are different from an engineering perspective, when we generalize these systems, we see that they have a lot in common. We have a source, we have a destination, and we have a path between those two carrying some sort of medium. And it is a very time-consuming process to route that path inside of a CAD model while maintaining code compliance and model coordination. So if it's such a ubiquitous problem and it is so time-consuming, why hasn't it been automated? Well, until recently, the only approach to automation for this sort of problem has been generative design. And in short, generative design just is not complex enough to handle the complexities that we see in modern day Revit and CAD models. But then generative AI came along and is capable of handling those extra complexities. But for construction engineering specifically, it brings about two issues. At first is data procurement. In order to train these models, we would need to take the hardworking data of construction engineers, and that data is your customer's data. And so that presents a lot of difficulties in training these models. And even if we were able to use that data to train models, I'm sure you've all seen the ChatGPT disclaimer at the bottom of responses that generative AI is susceptible to mistakes and hallucinations. And that's just untenable for construction engineering. So at Leaf Automation, we're pioneering the use of a new form of machine learning known as reinforcement learning. And it addresses both of the concerns with typical generative AI. First, it's completely self-learning, meaning we don't need to use training data to train these models. Instead, it works through this process of reinforcement, where if we take the snake game, for example, we can teach the snake how to complete the game successfully by rewarding it for moving closer to the apple and punishing it for moving away from the apple. And in engineering, we can add complexities like code compliance and engineering efficiency. Second, it's completely constrainable, meaning we can add all of that code compliance, and the engineering model is not a black box. We can physically restrain the model from doing things that would break code. So with both those things in mind, you can kind of see the parallels of the snake game to solar engineering, which is a form of system engineering here. We can see an engineer putting together a wiring design as they would on any other project by literally just drawing lines in AutoCAD, spending hours upon hours putting this design together here. And Black Veatch is not immune to this problem here. For commercial rooftop solar designs, Black Veatch engineers spend about 25 hours in total putting together these designs in AutoCAD, 15 for the line drawing, 8 for the labeling, another 5 for the wire sizing. But using our AutoCAD plugin branch, we cut that time down to just 10 minutes. And the way that we do that is we integrate our reinforcement learning capabilities directly into AutoCAD, the CAD platform that engineers are already using to design these systems. And taking a peek behind the scenes here, our reinforcement learning works by first picking a length of path, then a location to drop that path in, and in between choosing the path for that to land in. And it seems a little all over the place at first, but you can tell by the very end, it works everything together. It's got that pre-planning, and it puts everything together in the most optimal way, oftentimes better than a human would. And that's what really sets us apart in the construction engineering market, specifically for solar. There are a lot of existing competitors for CAD automation, but with the electrical design, fully automated capabilities that we have, it really sets us apart and allows us to add additional features that are only available to us because of those automation capabilities. And the solar industry is very excited about these capabilities. In addition to Black Veatch, we have 5 signed pilot contracts, an additional 11 pilot participants, over 150 individual end users who have found us to sign up for our beta, and a lot of backers from the industry to help support our efforts. Now, for the Black Veatch Ignite program, our goal was to install our AutoCAD plugin on Black Veatch devices, iterate based on the feedback, recreate an existing projects to measure the design accuracy and the time it took, and then develop and post a case study with the results. Now, unfortunately, We ran into issues with the Black & Veatch cybersecurity, but your guys' standards are so excellent that by the time we become compliant with Black & Veatch, we'll be able to get integrate anywhere. We were also able to iterate the product according to the robust Black & Veatch standards. We were able to accommodate the workflow to the engineer CAD technician relationship that you guys have here. And we measured the plug-in time savings to be about a 98% savings for these CAD-related tasks. Now, if you remember at the beginning of the presentation, I introduced commercial systems engineering as a wide problem, and we're not just focused on solar. Our vision is to take reinforcement learning and horizontally diversify it into all sorts of engineering applications. So that's what we spent the rest of our time during the IgniteX program doing, is exploring how we can bring this into CAD programs like Revit for new and more complex engineering systems. So we interviewed various engineering disciplines to understand these problems more intimately. We gathered that critical information so that we could start building this 3D reinforcement learning environment. And we were actually able to create the world's first environment for engineering and begin early training on that process. And that's what and this is what that looks like here. Over 150 hours of dev work went into this, over 500 hours of training on GPUs. And that left us with a model that was able to connect two endpoints in a 3D model and do so with avoiding obstacles. And you can see how this problem is a generalization of what we would be doing in a Revit building. And this is just a proof of concept for now. But what we want to be able to do is extend the capabilities for branching, like you would see in like a typical HVAC system, and then begin introducing in real building environments that you would see inside of a Revit model. Now, this is where Black & Veatch comes in, the engineers. Because we're not training our models on data, we ourselves need to understand these problems very intimately. We need to know everything about the CAD models, the code and compliance that goes into designing these systems, the engineering, and the tips and tricks that your engineers have learned over their careers in order to train these models. And so right now we are seeking to raise a $3 million seed round to help support these efforts. It's going to go into research for 3D scale-up, product development to diversify those efforts, and growth for our solar application. In terms of Black & Veatch goals, we're looking to formalize a relationship with Black & Veatch Investment, leverage your engineering talent to help build our 3D machine learning capabilities, and deliver a Black & Veatch pilot for our first Revit automation within 2 years. Here's our team making this possible, besides being our CEO, and I'm our electrical engineering and general engineering lead. Vikram is our AI specialist with about 5 years at Amazon and AWS specialty. Ben and Jake round out our software engineering capabilities, coding the plugin and all of our cloud architecture. And Cooper rounds out our highly technical team with his business experience from Deloitte. And we have backing from institutions like Case Western, the University of Chicago, and the Department of Energy. So that's it. Thank you. From everyone here at Leaf, we're very thankful to the Black & Veatch IgniteX team. We've learned a lot. We had a really great time, and we look forward to working with Black & Veatch to extend our technology capabilities into all sorts of construction engineering applications. Thank you.